Today, I want to talk about a technology that many teachers and librarians and even school administrators may not have heard about yet. Um, but first, let me start by saying my name is Dr. Dana Siebel, and welcome to the Cognitive Edge, where we come together to share information, ideas, and um, whatever services that we can to help others um, get to where they have to go. Okay. Um, so librarians and school ministers may not have heard about a digital twin, it's called. And while the name may sound like something out of science fiction, digital twins are already being used in industries such as manufacturing, transportation, engineering, healthcare, energy, and city planning. The question that I wanted to ask today is simple. What happened when this technology, or what happens when this technology enters our schools and libraries? Um, because it probably will. And um, when it does, it could fundamentally change the way we understand educational spaces. We allocate resources, we maintain buildings, we organize libraries, and perhaps even make decisions about teaching and learning from that standpoint. But before we get excited about what digital twins can do, we also need to ask a much harder question. Um, that just because we can measure almost everything happening inside a school, I mean, really, should we? This is where the conversation becomes very interesting. Um, a digital twin is essentially a virtual representation of a real world object, environment, or system. So, but it's more than just a three-dimensional model. So many of you may think um, Roblox, how we have different looking models that the kids build, but it could be some of that. But a traditional 3D model is mostly it's static. A digital twin can continuously receive information from the real environment. And, imagine creating a virtual version of, say, for instance, our school building. Every classroom is represented, the library is represented, the cafeteria is represented, hallways, computer labs, offices, HVAC, wireless access points, lighting systems, makerspaces, and other facilities can all become part of that virtual environment. Then information from the physical school can be connected to the digital model. Sensors, sensors, they might report like temperature. Um, the network could report Wi-Fi demand or outages or bottlenecks or whatever may be happening. Library systems, they could report um, computer usage. Room scheduling systems could identify which spaces are being used. Um, 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 Energy systems could provide information about electricity consumption. So, maintenance systems could indicate which equipment is approaching the end of its useful life. It's true, you want to depreciate out. anything old and get new things in. The digital twin becomes a living representation of the physical environment. Imagine being a school, say, administrator. You're considering converting an old computer lab into a uh, collaborative, say, learning space. Traditionally, you might examine enrollment numbers, talk with teachers, look at room schedules, inspect the spaces, and make your best judgment. These are still valuable steps, um, but really, with a sophisticated digital twin, you might also be able to simulate the change. Um, you could ask, for instance, what happens to traffic patterns if this room changes? Um, where will students go during certain periods? You know, will Wi-Fi capacity be sufficient? And will nearby classrooms um, experience additional noise or problems, or will the new space actually be used? Could another area of the building be, say, a better choice for this? Instead of simply making a change and hoping that it works, administrators may eventually be really, really able to model the consequences first. Think about how powerful that could become. I mean, it's amazing. Schools they're enormously complicated environments, very complicated. Um, a single building contains hundreds or sometimes thousands of people, and there's schedules and classrooms and technology systems and transportation and systems and food service and heating systems and security systems, libraries, athletic fields, special education, and many other moving parts. Most of these systems generate information, but historically, much of that information has really remained isolated. Um, the facilities department has one set of data, the technology department has another. Um, Everything is very just antiquated. The library has a third set, which is completely different. Administrators, they have scheduling information. Teachers, they have classroom information. Um, there's so much. A digital twin could potentially, I mean, really connect some of these systems into one single environment. Um, and that could allow schools to see patterns that are difficult to recognize today. Consider something as simple as classroom usage. Many school buildings were designed decades ago. Um, Educational practices have changed dramatically since these times. Um, some rooms may be overcrowded, others may be underused, certain areas may become congested between classes. and other spaces may retain or remain empty for large parts of the day. Um, a digital twin can really help administrators understand how the building is actually functioning rather than how they assume it to be functioning. Libraries could really benefit in similar ways. Um, with, um, for instance, imagine a school or public library with a digital twin. The library could analyze which areas receive the most use. Um, are students choosing individual study spaces or collaborative tables? And is there a reason for that? What does the makerspace, or when does it become the most busiest? I'll look into that. Which computers are being used? That's very important because that means that some of the computers are not in the right area. Are charging stations located where students actually need them? Um, are there areas that appear attractive in a floor plan but rarely get used? Um, are students struggling to find quiet areas during certain times of the day? I've seen this come up so many times over the years. It just happens. Um, this could change the way librarians really think about space. And traditionally, libraries have frequently made decisions based on circulation statistics, observation surveys, and professional judgment. Those tools, they remain important, but more so, the digital twins could add another layer of information. Instead of asking only how many books were borrowed, librarians could begin asking how many people actually interact with the entire learning environment, or where do students stop, or where do they collaborate, or where do they avoid, or what resources are difficult to access. Um, when areas become, what areas become crowded, what areas don't, and why, the hypothesis, would we, want to speculate there? Where might furniture need to be moved? The library could become something closer to a continuously steady learning ecosystem. That idea could be incredibly powerful, um, but it should also make us slightly uncomfortable. Um, once we begin talking about continuous studying educational environment, we quickly move from understanding buildings to understanding people. And this is where digital twins create serious ethical questions. Imagine a digital twin that tracks movement through a school. At first, that sounds pretty useful. Administrators could identify overcrowded hallways. They could improve evacuation. Um, they could understand traffic around cafeterias and why it gets so um, focused around the cafeteria. The principals could identify locations where students frequently gather, um, but The question is what happens when the system begins identifying individual students? What happens when movement data becomes behavioral data? What happens when artificial intelligence begins analyzing those patterns? Suddenly, the system might say that a particular student spends too much time outside of a classroom. Perhaps another student frequently visits the library, um, and another student repeatedly arrives late to certain locations. We have both students, and the technology may identify patterns, but understanding a pattern is not the same thing as understanding a person. Um, and this is what we really need to be very careful of. Um, the distinction is absolutely critical. Human beings are complicated, as we know. Students are even more complicated because they're developing socially, emotionally, intellectually, and physically. A data system might identify that a student repeatedly leaves a classroom. Um, the system, it sees a pattern, and a teacher may understand that the um, reason behind the pattern. Perhaps that classroom is overwhelming right now, or perhaps the students are experiencing anxiety. Perhaps the students um, have, very severe disabilities. Perhaps there is a peer conflict. Um, Perhaps the students simply need a few minutes to regulate emotions. And I agree, and I couldn't agree more. Um, the data, it sees movement, and it takes time, but it does. The educator really sees contexts, really. This is why we cannot allow digital twins or any artificial intelligence system to convince us that measurement actually creates understanding. It does not. More data does not always produce more wisdom. Sometimes it simply produces more data. And this is one of the central challenges facing education as technology becomes increasingly sophisticated. We're entering an era in which almost everything can potentially become measurable. Attention can be measured in so many ways. Movement can be measured so many ways. Network activity can be measured in so many ways. Library usage can be measured in so many ways. Assignment completion can also be measured in so many ways. Um, Attendance can and is measured, and classroom participation can be measured, and it usually is. Environmental conditions can be measured. Digital activity can be measured. Eventually, schools could generate enormous amounts of information every single day. But my question is, Who does the data belong to? Um, you know, the challenges will be really deciding what information actually deserves to be collected. Um, that is a very different question. Technology companies frequently begin with the question, what can we measure? Educators need to begin with a different question. Why are we measuring it? The question should come first, really. And if the answer is that the information will improve student learning, safety, accessibility, building efficiency, or educational opportunity, then collecting the data may make sense. But if the answer is simply that the technology allows us to collect it, um, that's really not good enough. Schools should never become laboratories in which children are continuously monitored simply because monitoring technology exists. There must be really clear limits. There must be transparency. Students should understand what information is being collected. Um, Parents should understand. Teachers should understand. Um, it's mission critical that everybody, like librarians and administrators, they all should understand the information going in, and there should really be policies governing who can access the information, how long it's stored, what it can be used for, and when it must be deleted. Those conversations really need to happen before digital twins become common in education, not afterwards. We've seen this pattern before, and a new technology enters schools because it appears useful. Adoption may happen quickly. We shall see. Only later do people begin asking difficult questions about privacy, cybersecurity, ownership, bias, and unintended consequences. Digital twins will give us an opportunity to revise or reverse the pattern. Thank you for watching um, my class and or my speech, and I hope you have a wonderful day. Thanks. Have a great day. Bye bye.